Welcome back to the channel. Today we're going to take a look at an integral, and it's an interesting one. It's a little bit different in the sense that it doesn't follow any particular pattern as far as I can tell. You can see here that I've got a base of 2x minus 3 in the top with a rational exponent as well as the denominator, but the plus one's kind of making it tricky. So there's a little trick to this one, which is what you could do is you could take the base out because they're the same. That's sort of something that you can use here. So what I could do is take the 2x minus 3. Oh, by the way, make sure you try this question first. So if I take the 2x minus 3 and I sort of take it out of play for a moment and substituting it with some other variable, a dummy variable. And so now I can do a little better than that. Do you notice that because these are rational exponents, I could clear those exponents by choosing to take u and raising it to the power 6. Because if I plug u to the 6 into 2x minus 3 in both the top and the bottom, you can see what's going to happen. The half here is going to interact with the 6. And the third here is also going to interact with the 6. So it's going to make the integration a lot easier. Let's see how that works. Okay, so I'm going to come back to this integrand. So equals the integral of, place the u6. Now if I put u to the 6 in here, it's going to interact with the half, do you see? So that's going to become u to the 3. So upstairs I get u to the 3. And then downstairs, I got to come back to the dx. I'm going to get u to the 6 to the 1 over 3, which is u to the 2, right? So u to the 2 plus 1. And even now you can sort of see what's going to happen here. Notice the denominator. It looks like a special denominator. We'll come back to that. If I'm going to switch out the x for the u, then the dx has to be swapped out too. So what I'm going to have to do is take this substitution and differentiate it with respect to x. So I'm going to take d by dx of that, and I'll take it term by term. The derivative of 2x with respect to x is 2. The derivative of negative 3 is 0. Equals, now I'm going to take the derivative of this with respect to x. So I'm going to apply the power rule, bring the 6 down. U to the 5, subtract 1. And don't forget, now you've got to do some implicit differentiation. So I have to differentiate u with respect to x. So that's going to be du by dx. And that's not bad, because what that allows me to do is take the derivative and break up the differentials. So I could take the dx over here and bring the 2 over. That's going to collapse the 6 to a 3. So you can see here that dx excuse me, is going to be equal to 3 u to the 5 du. So what I'm going to do is come on over here back to the integral, and I'm going to plug wherever I see dx, I'm going to put the 3 u to the 5 du. So I'm going to put in there, and I'll put it in brackets. So 3 u to the 5 du, and there's my substitution. Okay, I'm just going to clean this up a little bit. The 3 is a constant. It can come out of the integral. So that's going to be equivalent to a 3 integral. Well, there's u to the 3 times u to the 5, which is u to the 8 du, divided by, well, u squared plus 1. U squared plus 1. Not much that I can do there. So, okay, now I've got this one to contend with. So u to the 8. Now the numerator, do you notice, is pretty high in degree relative to the denominator. There's a big difference, which means a direct substitution probably isn't going to work. So what I'm going to do is I'm going to sort of simplify it. It's not fun, but I'm going to divide. I'm going to take the integrand and I'm going to do a division. So what does that mean? Well, what I'm going to do is I'm going to take u squared plus 1, and I'm going to divide it into u to the 8. U to the 8. So I'm going to do a little bit of old-fashioned long division here. How do we do that? Well, we just start by dividing. So u to the 2 goes into u to the 8, u to the 6 times u to the 6. because u to the 6 times u to the 2 is u to the 8. So u to the 8, and I have to multiply that also by the 1. So that's going to be plus u to the 6. And don't forget that division is just, you're just subtracting multiples of the divisor until what you have left over is smaller than the divisor itself. So I'm going to do a subtraction here. And then when I do that, I end up getting a negative u to the 6. Keep going. U to the 2 goes into negative u to the 6, negative u to the 4 times. So negative u to the 4. And so negative u to the 4 times u to the 2 is negative u to the 6. And negative u to the 4 times 1 is negative u to the 4th power. Draw the line, change the signs. In other words, you're subtracting. And then add vertically, so I get a u to the 4 here. U to the 2 goes into u to the 4, u to the 2 times, right? Plus u to the 2. Multiply it down, u to the 2 times u to the 2 is u to the 4. And u to the 2 times positive 1 is u to the 2. Draw the line, change the signs, add vertically. And you're going to get a negative u squared. We're almost done. Look at this. So u to the 2 goes into negative u to the 2 negative 1 times. Everybody knows that. And then negative 1 times u squared is negative u squared. Negative 1 times positive 1 is negative 1. Draw the line, change the signs, add vertically. Boom, 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 boom. Okay, why did I do that? Well, look. The division statement would be the quotient plus the remainder divided by the divisor. And I'm feeling pretty good about this because I can easily integrate that. So I'm going to rewrite my integrand. I'm going to come over here and I'm going to use another way to write it like this. I'm going to say that's equal to 3 integral of the quotient, which is u to the 6 minus u to the 4 plus u to the 2 minus 1. And this is like a division statement, plus the remainder all over the divisor, which is u squared plus 1. And so that's what I've got to deal with. And this is looking really good because this one is a recognizable integral. What I'm going to do, because I don't need this division anymore, I'm just going to remove this. I'm going to erase it. So I have a little extra space to carry out. Those colors sort of bleed into the board. It's a cheap board. So what I'm going to do now is I'm going to take that thing, and I know you guys are thinking it. Don't forget to write the dx. You got to have that there. Okay, then the rest is really rather academic. I'm just going to integrate term by term. So this is going to be equal to 3 bracket. The integral of u to the 6 is u to the 7 by 7. And u to the 5 by 5. And u to the 3 by 3. This is just like cutting through warm butter, right, with a hot knife. And then I also have to deal with this. Well, that's the arctan. That's a well-known, it's on a formula sheet. So that's going to be positive arc rival, arctan of u, close your bracket, don't forget to introduce your constant of integration. Okay, well that's good. Now, I still have to put the u back because this was written in terms of x. So let's come on up here. This was the original expression here. So I want to know what u is. So what I could do is raise both sides to 1 over 6, right? So if u to the 6 is equal to 2x minus 3, then I could simply raise both sides. What I do to one side, I do to the other. 1 over 6, 1 over 6. And you can see u is just 2x minus 3 to the 1 over 6. I'm going to plug that back in. So that's equal to 3. I'm just going to bring the 3 through as well. So that's going to be 3 over 7 times u. Well, u is this, 2x minus 3. 2x minus 3 with an exponent of 1 over 6. But there's a 7 there already. So 7 times 1 over 6 is 7 over 6. Do you see? You can break this into steps, but you know, condensing it's going to make it go faster. So minus 3 over 5. So 3 over 5. And then the u here is going to be a 2x minus 3. Again, 1 over 6, but that's going to come in contact with the 5. So 5 over 6. We're doing good. Now look, the 3 is going to be multiplied by 1 over 3. So that's a wash. Plus 2x minus 3. And then 3 over 6, which is going to be a half. Okay. And we're doing okay here. And then minus 3. So minus 3u, which is 2x minus 3 to the 1 over 6. And then the 3 gets brought in on the arctan. I'll just write it here. Plus 3 arctan of u. And this is u right here. So I'm going to put it 2x minus 3 to the 1 over 6. And again, don't forget your constant of integration. So there you have it, simply using a substitution that isn't as necessarily familiar or common to rationalize those powers, to get rid of those halves and thirds, 1 over 3, by using the lowest common denominator of 2 and 3. And it worked out pretty good. All right, if you like this video, don't forget to slap a like on it, and don't forget to subscribe if you haven't already, and I'll see you right back here in the next video.